So, okay, on this first review again, we're looking at Unit 4. And one of the things we looked at in Unit 4 was exponential growth and decay in a couple of different ways. Okay, first, our domain values, okay, if we remember back, are our x values. And it's our x values in the graph as we move from left to right. So as I go from negative to positive infinity. And in this example, that's actually what my domain would be. Because this graph, even though it looks like it runs into here, I can see the arrow down here. This is going to keep going left forever to negative infinity. And this is going to keep going up and expanding to the right to positive infinity. Now I want to make note of one thing. What we're writing in here for the actual domain and range is strictly for this example. It doesn't mean your domain every time is negative infinity to infinity. It depends on some things. Okay, but for exponential growth and decay, typically it is. My range is my y values. Okay, my y values from the bottom to the top of my graph. Now my graph doesn't go down forever. It goes down, 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 and then it kind of tears off right here where my y value is 0, because that's what it is along the x-axis. So my range would be from 0, its bottom value, to infinity, which is going up to the top. Okay, so that's how I check out my domain and range in any graph, basically. And then end behavior, which we also talked about before, basically is going to go along with my domain and range, and here's what I mean. My x's are always going to be positive and negative infinity, okay? So as my graph is moving to the right, and I'm looking at f of x, which is a fancy way of saying y, my y value is going up towards positive infinity. My f of x, okay, my y, as I go to the left, is getting close to 0. And so if you look at that for a second, you look at the y values, you've got infinity and 0. Oh, they're the same as these were. So basically, my end behavior, my f of x, or my y, you can write it either way, would be my range values. My x values my left and right are going to be my domain values, just like they were up here. So really, it's not that tricky of a thing to do. Okay? And then just as a general note, if I'm trying to figure out if a graph is growth or decay, if I'm looking at it visually, okay, it's going to increase from the left to the right if it's growth. Okay, my base value would be 1. It probably looks something like the graph that I've got here. Okay. However, if it's decay, and I apologize, there's going to be a couple of minor changes to make in here as we go. Okay, typically when it's decay, my graph is going to be decreasing from left to right. It's basically going to go downward. It's going to be the inverse of that other graph. But again, I can even look at that through a base. So if I had something like y equals 3 to the x, that'd be growth. My base value is greater than 1. However, if I had something that looked like this, okay, 1/2, my base value is less than 1. It's going to be decreasing. And we get that set that way. So that's part of what we did in Unit 4. So then the next part becomes solving logarithms, okay? We're going to use the base to solve it. A log and its base number are inverses. So for instance, if I have like log of 4 and 4, those things are opposites. Those things cancel each other out. So if I see this where I want to solve for x and there's a log 3 there that I need to get rid of, here's a word we haven't heard in a while. We're going to exponentiate. We're going to take whatever that base number is And we're going to use that as my opposite to get the log out of there. So I get those out of there. And then again, exponentiate means those values become exponents. Okay, it's not 3 times 4, it's 3 to the 4th power, which would be 81. Okay, so it's not hard, it's just remembering, what my rule is, because I can't just divide by log 3, that wouldn't work. However, we have to be careful. If the log isn't isolated yet, if it's not by itself yet, I'm going to zoom this a little bit here, so just give me a second. So here, I can't do the exponentiate right away. I can't do the 2 right away, because this has got to be alone before I do that. So I'm going to go ahead, I'm going to get the 4 out of there. And at this point, now I can exponentiate. Now I can use that 2 to get the log base 2 out of there. And I end up with 2 to the 7th power. Because again, we're working with an exponent. And I get my value with that. Okay, so I know it's been a while, and that's why I'm hoping this will help out a little bit as you're starting to play with these a little bit. Okay. So as we head to the back, if I figure out a way to flip this paper over, okay. Inverses with logs. If we're looking to find the inverse, we switch x and y, and we solve for y. So we're going to be doing that using the log and its base inverse rule that we just did on the last problem. So, step 1, switch the x and y around. Okay. Step 2 is to exponentiate. Because again, when I'm on this side with this log base 5 of y, what's in my way? The log base 5. So I'm going to use the 5 to exponentiate on both sides. And I guess I could have done that without completely rewriting it, but that's okay. Because then those 2 guys will cancel. And again, I've got to stress to myself exponentiate. It's 5 to the x power, not 5 times x. And I get my answer, and I'm good. So we're kind of going about it that way. So then another part of that, we did a lot in Unit 4, was switching between exponential and log forms. Okay? So when you're looking at either of these setups, it's my log and then its base number. The exponent will be after the equals, and the answer will be here. So when I'm trying to go back and forth, this is in a log form, I go, okay, so 4 is my base, 2 is my exponent, and the answer is just the number next to it. And you're like, oh yeah, 4 squared is 16. Okay, that makes sense. Because that's all basically that it is. And then it's just the opposite on the next one. Now I got to think a little more. I'm like, okay, think about this. So I've got a log, my base, okay, my big number here, so my base, my answer goes next, and the exponent goes on the other side. Base, exponent, answer. So that would be the logarithmic form of this. 9 to what power equals 1 over 81? Negative 2. Because the negative 2 makes my 9 flip, and 9 squared is 81. And then the last thing we did with our logarithms was expanding and condensing. Okay, so when we expand, multiply becomes add. Divide becomes subtract. And then one more switch here we've got to make. I flipped my 2 things around, and I didn't notice this until this morning. And exponents become coefficients. I mix these up on my condense and my expand here. And one thing that I kind of like to stress to make sure that this is easier is that you really should do these in the order that I have them here. Multiply and divide are a little bit interchangeable, but doing the exponent part last will save you a lot of grief. So when I actually get to doing these, so like in my first example, I'm like, okay, I see multiplication here. These two are being multiplied. So I've got to keep my log each time. Okay, so I don't get to write log 8 just once. I need to write it twice. So for this part, that times becomes plus. The divide becomes minus, still with a log 8 though. Every single term gets that. And then, if I have exponents, and I have 3 of them this time, all 3 of those exponents, when I'm expanding, turn into coefficients. So the 2 goes in front of my log 8 of x. The 3 goes in front of my log base 8y. And the 4 goes in front of my log base 8 z. And we're set with that. So once I see no more exponents, no more multiply, no more divide, then I know I'm done. So then I look at the next example, and I'm like, okay, I see a multiply. So that multiply will become an addition sign. But then I got to really stop and think about this for a minute. Because I'm like, man, that can't be all there is to do, but I don't see any minus. And I don't see any exponents because they're already coefficients. I can't flip those back up. That becomes the condensed part we're about to do. So for this one, that's actually as far as I can go. Okay, so I don't want to overthink this. I just want to kind of work through the steps a bit. And then when we get to the bottom here, the end, and we're condensing, we're doing the opposite. We're taking something that's really expanded and we're squishing it down into one logarithm. Everything just goes backwards. So again, my apologies that I'd flip-flopped these. So down here, notice in our order of to-do list, coefficients are now first. Coefficients are going to turn back into exponents. And subtract is going to turn back into divide, and add is going to turn back into multiply. So it's exactly the opposite of everything that we just got done doing up in the expansion. So if I follow the order here, coefficients are going to turn back into exponents. And I'm not a fan of trying to do multiple things at once, so we'll just go ahead and get those in. And then I look to see if there's anything else I should do. Ooh, I see a subtract sign. Now here's one other thing that's a little bit different than that first part was. And I'm going to write this up above as soon as we get this jotted down. A lot of times when you condense, it may be written in a different way. It might say write as a single logarithm. That's the same directions as telling you to condense. In other words, I want to get this down where there is one log with one base and everything else is smashed back together. So notice I didn't write log 4 twice, or like we did up in a couple of the examples above, write it 3 times. Okay? One logarithm. When we condense, they should look like, an original problem may have up in example 1 or 2. So I'd need to get to this part and then I'm done. And then my last one throws one twist in. This always drives people crazy. They're like, well, 3. So do I sing 3 up to the top? No. Well, why not? Because the 3 is in the denominator, and we always assume there's a 1 here. So I'm actually going to rewrite this so I don't do anything that will mess this up later. So that log base 2x over 3 is really 1/3. So once I get here, now we start all the rules. So I take those coefficients, turn them back into exponents first. Then I start working down the line here. I'm like, do I have any subtraction? Nope. Do I have any addition? Yep. Add becomes multiply. So, since we're going to our single logarithm, x to the 1/3 times y to the 5th. And I'm set. Okay? So that'll be something that's helpful for you as you're working your way through the review. So keep that handy. As always, I will have a key up front so you can see how things are going. If you're getting things answered, kind of seeing how that goes. And then just as an FYI, okay, not that we have to put this on here, but I'm going to flash it up here for just a second. The other thing you got today are just some hints I've got on how, and this would work in most classes, just some things on what you can do to study, okay? Looking at old notes, looking at practicing, repeating processes, going back to the website, which we just talked about before we started with this, or YouTubing. TeacherTube, that's kind of like YouTube just for teachers, but you can go in there and type in any subject you want, basically, and there'll be videos for it. I'm not on there since I've got the TeacherTube page. Khan Academy, some of you have come for that. I've seen matching games get made, applications, you know. You notice I'm all the way down at number 13, okay? If you've tried some stuff, do that. Use your technology that you like to use for crazy, frivolous things all the time and actually use it for something helpful, okay? Talk with some people. Figure out some stuff. If you know how to do it, tell somebody else how to do it. It'll reinforce it, okay? The books are up front. Try some odd problems, you know. Look around, look around, look around. And that's the best way you can kind of do this. So one review down, couple to go, and we'll see how